Today I'll be finishing off our historical survey by talking about David Hume, and then I'll be moving on to the first of the topics of general philosophy, the main topics that form the syllabus, and focusing on the topic that's most associated with David Hume, namely induction. David Hume, known at the time as the Great Infidel by some, was probably the greatest philosopher of this period, at any rate in my view. Scottish philosopher, unfortunately had nothing whatever to do with Oxford, lived from 1711 to 1776. His biggest and in many ways most famous work is the Treatise of Human Nature of 1739, that he went on to write in quite a wide range of fields, a lot of very interesting essays, which to some extent helped to found the science of economics. Adam Smith was a younger contemporary of Hume, whom Hume influenced a great deal. His inquiries, the two inquiries, are very famous. He wrote a history of England, which was for a long time the standard history, and published a lot on religion, including the dialogues concerning natural religion of 1779, published posthumously. It was such a dangerous work. If you want to read a truly great work of philosophy that is actually quite funny, then the dialogues is the place to go. I think certainly the greatest combination of philosophical originality, erudition, and humour to be found in the literature. Now, in many ways, Hume can be seen as building on Newton and Locke. From Newton, you get the general idea that the aim of science is not necessarily to aim for ultimate understanding of things, but rather systematization. Just as Newton, when it came to gravitation, didn't pretend to understand how gravitation works, he gave formulae that encapsulate how it works, the effects of it. So that is taken by Hume to be a model for how science in general can operate. And like Locke, in contrast to people like Descartes, he emphasized that the aim of science is not to get certainty. That is not achievable. We have to make do with probability. Now, take the fundamental case, forget about gravitation and weird things like that. Think about the motion of billiard balls. One billiard ball bashing into another. We see a white billiard ball moving towards a red one, the two collide. Why do we expect the red one to move? And Hume imagines a thought experiment in which Adam, the first man newly created by God, sees one billiard ball moving towards another, is asked to predict what's going to happen. Could he predict it? Well, according to Hume, he couldn't. He's got no experience to call on, so there's no way he can know in advance of actually experiencing the impact of balls and similar objects what's going to happen. So in fact, not only is gravity unintelligible, as we saw last time, many philosophers at the time wanted to say, actually even mechanical causation is pretty unintelligible too. We're used to seeing billiard balls bashing into each other, so we think we sort of understand why, but really there's no understanding to it. It's just habit. So the lesson that Newton drew in the case of gravity, and Berkeley generalized, as we saw in his instrumentalism, Hume wanted to draw as a quite general lesson of science, that intelligibility is not something that we can reasonably aim for in science. Ultimately, all we have is those systematic laws that codify the way things behave. It's a bit like Malebranche's theory, except without God, which is sort of paradoxical, but Hume wants to say that there is no real glue in nature, or at least nothing at all that we can remotely understand. All we can do is see how things behave, codify that behavior, and do our science on that basis. Ultimate understanding, forget it. Okay then, if all we have to go on is experience, where does that leave us? Where does that leave us in respect of scepticism, for example? Suppose I've seen lots of billiard balls impacting with each other. I've got used to the way they behave. Maybe I've done careful investigations and I've come up with some laws that seem to codify the way they behave. Conservation of momentum, the law of restitution, that sort of stuff. So I'm actually able to put this into scientific formulae and work out, when one billiard ball moves towards another, how in the past that collision would have happened. Does that give me a good reason for supposing that the next collision of billiard balls will work in the same way, will operate according to the same descriptive rules? Well, if past experience is to give me a good reason, it seems that I've got to have some reason for extrapolating from the past to the future. Some reason that will justify my taking that past experience as relevant to what's going to happen next. Well, it's not self-evident that that's true. It's not a matter of logic that what's happened in the past should continue for the future. My senses don't tell me anything relevant. Okay? That I'm seeing the same motion of billiard balls, but that doesn't tell me what's going to happen after they've collided. And if I try to appeal to experience, it seems that I'm begging the question. I'm taking for granted that experience is relevant to the future. So we seem to get a very skeptical lesson about induction, about inference from past to future. It seems that we can give no reason at all to justify that. We'll be coming to that in a little bit more detail later. So Hume's view on induction seems to take us quite a long way beyond Locke. Locke wanted to say against Descartes that we have to make do in science with lack of certainty. When we reason about things in the world as opposed to logic, there is no certainty to be had. But now Hume is saying it's worse than that. Actually, we cannot give any good reason whatever for supposing that the laws that we've gleaned from past experience will be applicable to what happens in the future. It seems that all of our scientific ambitions, everything, is based on a brute animal instinct. We just naturally think that the future will resemble the past. So in a certain respect, we're in no better position than the dog who, when you go for the lead near the front door, starts jumping up and down with anticipation of going for a walk. Why does it do it? Habit. It associates you going for the lead with going for a walk. It doesn't have any rational insight into the connection between the two. It's just habit. And we seem to be the same with billiard balls. Now, think about this in the context of the philosophy of the time. We've seen how much of the thinking of the time was imbued with religious thinking. We were seen at the time as creatures made in God's image. Man is the image of God, and the primary instance of that is human reason. Human reason was supposed to be a sort of faint image of God's reason. Just as God can see everything by immediate insight, so we, through mathematics and through science, are supposed to be able to acquire insight into the way the world works. Something in the same sort of way as God does. We're up there, intermediate between the animals and the angels. We're not merely part of the animal creation. Our bodies may be physical, but our minds are made of immaterial substance, which is quite different in nature. So we have this view of man as privileged, and Hume's attack on our rational faculties strongly counters that. It puts us back with the animals. It suggests that for all our cleverness, ultimately our rational faculties have a very earthy foundation in brute animal instinct rather than insight. So if we want to find out about the way human beings behave, the right way to do it is not by thinking of us as specially rational creatures. Rather, one should find out about the way humans behave by observation, experiment, systematization, generalization. You treat us as part of the natural world. One might suggest that modern-day economists would do well to learn this lesson. A lot of economic models are based on the assumption of perfect rationality. We've seen recently where that leads us. Hume's lesson is that actually humans in their behavior are far less rational than they like to pretend. Empirical investigation of how people actually work is likely to yield much better results than the assumption that we are perfectly rational. This lesson goes through to the Hume on free will. Hume in many ways follows Hobbes. He's a compatibilist. He thinks free will is compatible with determinism. As part of nature, human action is causally determined, Hume thinks, in exactly the same way as billiard balls. Someone who knew all the laws that govern the way we behave would be able to predict reliably what we would do. Free will is simply having the power to do as our will dictates. Now, you might think that that is going to undermine morality. If we are ultimately causal parts of nature, working according to causal laws in the same sorts of way as billiard balls, how does morality get any purchase? Well, Hume's answer to that is to found morality on sentiment, on fellow feeling, empathy for other people. His idea is that we naturally identify with others. When we think about another person's pain, to some extent we share that pain. Therefore, we have an interest in relieving it. We grow up in families. Families get wider into social groups. By mixing together, we learn to care for each other, and we find that codifying rules of behavior makes sense on that basis, because we actually feel a passion to do good to others. We are not purely selfish creatures in the way that Hobbes had thought. So Hume gives morality a basis in our brute human nature. Again, it's not a matter of pure reason. You can't found morality on logic, but you can found it on the way we are as human beings.